Let us get started with an overview. Week 4 to 5, House Price Prediction with Ames Housing Data. Welcome to this hands-on introduction to regression using real housing data. In this lesson, we will predict house prices with the Ames Housing Dataset. You will learn to load data, explore relationships, build your first regression model, and make predictions. House price prediction is a core data mining project and a popular interview question. Running the cell now. Are you ready? Let us get started. We are beginning by importing all the necessary libraries for data analysis, such as pandas, numpy, matplotlib, seaborn. We also suppress annoying warnings so our notebook stays clean. First, we bring in Python libraries for handling data, math, and plots. Turning off warning messages keeps our output tidy. Pandas helps us load and work with tabular data easily. Numpy is great for numerical operations and arrays. Matplotlib lets us create basic visual charts and plots. Seaborn allows us to quickly make pretty graphics for data relationships. We set the random seed to 42 for reproducibility. Running the cell now. This initial code block sets up the environment for our house price prediction project by importing essential libraries for data manipulation, visualization, and numerical operations. Although there is no visible output yet, this step is crucial to prepare for loading, exploring, and modeling the Ames housing data. It ensures that warnings are suppressed to keep our workspace clean as we proceed. You will use these libraries in most data science and mining projects. Now, let us load the Ames housing dataset straight from the web. We show its size and a peak at the beginning. This cell loads our housing price dataset. We define the address where our data lives online. The data comes in as a table we can view and process. Printing the shape shows us how many houses and features we have. We print the first 3 rows to see real data values like longitude, latitude, rooms, and more. Running the cell now. This output shows the initial shape and first 3 rows of the Ames housing dataset, with 20,640 samples and 10 features, including key columns like median_income and median_house_value. Notice the mix of numerical features, e.g., total_rooms, population, and the categorical ocean_proximity, which we'll use to explore relationships and build regression models for predicting house prices. Try loading other datasets later for practice. Let us explain why regression matters with house prices. Why use regression for house prices? Regression helps us predict values, like a home's market price, based on its features, bedrooms, location, size, and more. This is very useful for real estate, banks, and new home buyers. Running the cell now. House price prediction is also used by insurance, rental platforms, and city planners. Let us learn what types of data we have and if there are any missing values. We are checking details about our data columns. Columns tell us what facts we know about each house, like location and number of rooms. Running the cell now. This output shows the structure of our housing dataset with 20,640 entries and 10 columns, including key features like location, number of rooms, and median income. Notice that most columns have complete data except total_bedrooms, which has some missing values to consider. Understanding this helps us prepare the data correctly before using regression to predict house prices. This is helpful to know what is numeric and what is categorical data. Missing data is a common problem in real projects. Let us see if anything is missing. We are checking how many missing values are in each column. Missing values need to be fixed before we build our model. Running the cell now. This output shows the count of missing values in each column of our housing dataset, revealing that total_bedrooms has 207 missing entries while all other features are complete. Noticing missing data is crucial because regression models require clean, complete inputs to accurately predict home prices. Addressing these gaps ensures our predictions reflect true property characteristics. Handling missing data is a key skill in data mining. For a simple start, we just remove any rows with missing data for now. We are making a new table without missing values. We only keep safe, complete data to avoid errors. Now we check our clean dataset size after dropping incomplete rows. Running the cell now. After dropping rows with missing values to ensure clean data, the dataset now has 20,433 rows and 10 columns. This shows we still have a substantial amount of data to train our regression model, which is important for making reliable house price predictions based on various features. Later, you could try filling missing data instead of dropping it. Statistics tell us how the data is spread out. Let us look at averages, max, and minute values. This shows us examples of typical house sizes, prices, and other numbers. Summary stats help us spot outliers or weird data right away. Running the cell now. This output shows summary statistics for key housing features like total rooms, bedrooms, and median income, giving us a sense of their typical values and ranges across 20,433 homes. Notice the wide variation in features such as total rooms, which will impact price predictions in our regression model. Understanding these distributions helps us anticipate which variables might be most influential in predicting median house values. It is good practice to always check these descriptive stats at the start of any analysis. Let us plot house prices. Charts make patterns much easier to see at a glance. We set up a chart shape to fit our plot. We use a histogram to see the range and most common prices for homes. Adding a density curve lets us see the smooth shape of price ranges. The chart title lets us know we are focusing on house prices. Here, we give a label to the x-axis so viewers know the value scale. The y-axis label shows how many houses fall into each price bin. We display the chart so you can look for outliers or popular price bands. Running the cell now. Here, we see a histogram displaying the distribution of house prices in the dataset. Notice the shape. Prices are spread over a wide range, often skewed right with many lower-priced homes and fewer high-priced ones. Understanding this distribution is key for regression, as it shows how prices vary and helps us model predictions more accurately. Notice if most homes are affordable or if there are expensive outlier homes. Now, let us see which features best explain house prices. Exploring relationships, features versus price. Some factors impact price more than others. Let us investigate. Running the cell now. Think about how location, room number, or income might affect prices. Next, let us plot household income against house price to see their relationship. This comment explains we are comparing house price and median income. We set the size of the plot to make it clear and easy to read. We create a scatter plot showing median income on the x-axis and house price on the y-axis, using partially transparent points. We add a title to describe what the plot is about. We label the x-axis as median income to clarify what values it shows. We label the y-axis as house price to clarify what values it shows. We display the plot on the screen so we can see the visualization. Running the cell now. This scatterplot reveals a clear positive trend between median income and house price, indicating that higher incomes generally correspond to higher house values. Notice the spread of points widens at higher income levels, suggesting more variability in house prices as income increases. This visual helps us identify median income as a key feature influencing house price in our dataset. Do you spot a trend? Try this with other features such as rooms or location. Time to set up the features, inputs, and the value we want to predict. We pick for columns that could influence house prices. These will be the predictors used by our model. The column we want to predict is called our target variable. Running the cell now. Here, we've selected key features and the target variable to prepare for regression analysis. Notice that the features include income, housing age, room count, and population, all of which may influence house prices differently. This setup lets us systematically explore which factors have stronger relationships with the median house value. You can try adding or removing features to improve results later. It is important to test our model on new data, not just the data we train it on. We import a tool to split up our dataset. This keeps part of the data for training and part as a fair test. 80% of data will be used for training and 20% for testing. Running the cell now. This code splits the data into training and testing sets, ensuring we evaluate our models fairly on unseen data. Notice that 80% is used for training and 20% for testing, which helps us understand how well price predictions generalize. This step is essential before exploring which features most impact price. Testing on new data helps avoid overestimating how smart our model is. Now let us actually train, or fit, our model so it can learn to predict house prices. We're building a simple linear regression model to predict values. First, we import the linear regression class from scikit-learn. Next, we create an instance of the linear regression model. Finally, we fit the model to our training data to learn the relationship. Running the cell now. Here, the output linear regression confirms that our model has been successfully created and trained using the training data. This sets the stage to explore how different features influence the price by examining the model's coefficients and predictions next. Notice that this step is about building the foundation for understanding feature impact on price. Most real estate sites use similar algorithms for predicted values. Let us see what our model predicts for house prices using just a few features. We use the trained model to predict house prices. We generate price predictions for the test dataset input features. We display the first 5 predicted house prices. Running the cell now. Here we see the first 5 predicted house prices generated by our trained model, giving us a glimpse of its estimates on new data. Notice the variation in values, which reflects the model's attempt to capture different feature impacts on price. This output helps us evaluate how well our model understands the relationship between features and price before deeper analysis. Predictions like these guide mortgage offers and renovations. After prediction, it is time to check how well our model worked. This section introduces how we will evaluate the model's performance. We import functions that calculate common regression error metrics and the R-squared score. Calculate mean absolute error to see the average magnitude of prediction errors. Calculate root mean squared error to penalize larger errors more than smaller ones. Calculate a squared score to understand how well the model explains the variability of the target. Print the mean absolute error to show the average prediction error in simple terms. Print the root mean squared error to display how large the typical squared error is after square rooting. Print the R-squared score to indicate the proportion of variance in the target variable explained by the model. Running the cell now. This output summarizes how well our model predicts housing prices, with error metrics showing average prediction deviations, about $60,867 in absolute terms and $81,256 when giving more weight to larger errors. The R-squared score of 0.52 indicates the model explains roughly half the variance in prices, highlighting that while some features are influential, there's still room for improvement in capturing all price drivers. This evaluation helps us understand the model's current accuracy as we explore which features impact price most. Try new features or models and see if you can raise that R-squared score. Let us use a scatterplot to check if predictions match true prices. Good predictions make a diagonal. We draw a plot comparing the real and predicted values. We create a new figure with a 6 by 6 inch size for the plot. We plot points where X is the actual price and Y is the predicted price, with some transparency. We label the X-axis as actual price to show what values are there. We label the Y-axis as predicted price for clarity. We add a title describing that the plot compares actual and predicted house prices. We draw a red dashed line showing where predictions perfectly match actual values. We display the plot so it shows up in the output. Running the cell now. The scatter plot compares actual house prices to the model's predicted prices on the test set, showing how closely predictions match reality. Notice most points cluster along the red dashed line, indicating good predictive accuracy, which helps us understand how well the selected features capture price impact. This visual assessment is key to evaluating the relationship between features and target price in our model. You can use this plot to spot where your model does best or struggles. Now, you will fill in values and see the model's prediction for a house you invent. Practice, try your own prediction. Let us make our own house price prediction. Enter a few numbers when prompted. Running the cell now. Complete this and see how close your price is to real houses in the data. Let us interact. Type your own numbers when asked, and our model will guess the house price. This prompt asks you to enter a number for household income. Next, give the typical home age for your imaginary neighborhood. Enter how many rooms homes usually have in this area. How many people live in your target block? We arrange your numbers so our model can read them. Now, the model makes a prediction just for your inputs. You get a price based on what you entered, like an instant estimator. Running the cell now. This output shows the predicted house price based on the custom inputs you provided for median income, housing age, rooms, and population. The key takeaway is how the model uses your specific data values to estimate a price, demonstrating the practical use of prediction after training. Notice how altering these inputs can directly impact the predicted price, reinforcing the concept of making predictions with new, user-defined data. Try changing your numbers to see how it affects the price. How high can you get? Do not forget to like and subscribe for more hands-on lessons. Here are some extra ideas if you want to challenge yourself after this lesson. Challenge: extend this notebook. 1. Try adding more features to the model and check if error goes down. 2. Try replacing linear regression with a random forest regressor. 3. Visualize how feature importances change. Running the cell now. You are now ready to explore more powerful models and techniques. Let us summarize what you have learned in this session. Lesson recap and next steps. You learned to load and clean real housing data, explore and plot data, build, test, and evaluate a regression model, make your own predictions. Keep practicing and try out new datasets to build your confidence. Running the cell now. Every step you try makes you a stronger data scientist. Thank you for joining this hands-on lesson. Thank you. Practice and subscribe. That is all for house price regression. Practice, try the challenge, and subscribe to stay on track with your learning journey. Running the cell now. We appreciate you learning with us. See you in the next lesson.